if I want to keep track of names, okay, it gets tedious when you have a lot of them. And what we need is a mechanism to more easily represent a whole bunch of something. And the way to do that is with what are referred to as arrays. And the way you specify an array is simply you give it you say the kind of array that you want. You give it a name, just like you give all variables a name. About list of names. And then you use the square braces, and inside of the square braces you put a number. And that is now not creating one string, but it's actually creating 131 strings. Let me create 132 strings. And the way that looks in memory, which shouldn't be too mind-boggling, that name, we'll use it. All right. Is a string is going to take up a certain amount of memory. Actually, that's probably not the best example because strings are rather complex under the hood. But I'm gonna simplify them a little bit and say that a string takes up this much memory. So if I'm going to have 132 of them, I have to do this for a while, which is a great way for killing time. And dot, 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 until you get to the end here. And then this whole thing would be collectively referred to as, let's look at our example here, list of names. And for you to access a particular one of these, you have to go through an interesting process. So I'm going to show you the really weird way, and then I'm going to show you the normal way. If I want to use list of names, and I just say list of names, and I want to do something like this, let me actually try compiling that. Okay, what I get is if I run this and I try to print out the list of names, I get this really weird number, which is actually corresponding to this number here. And so what it is it's an address in the machine where your address begins at 0 or 1 and it goes on to some absolutely huge number in this day and age. And so the position in the computer's memory that was set aside for, let's look at the code again. this is line 15 that we're seeing output, it is showing where the very first memory location is that starts off these 132 names. Okay. So if I want to access one of these, I have to do a couple things. First is I have to add a number to this variable and to tell it which one of these I want. So if I want the first string, how much do I add to that number? How much do I add to 100 to get to the first string? 0, right? I'm already at the first string. So the first string is going to be at position 0. The second string, I'm incomplete here. So what you would say is you'd look at this drawing and you'd say, well, you'd add 2 because the way I've written it, there's 1, 2 bytes. Actually, what happens under the hood is that the compiler will compensate for the size of this variable. So a string may be this big and a floating point number may be this big. It doesn't matter. If I say +1, if it's a string, it'll do the right thing and go over this far. If it's a float, it'd go over this far for a single float. Again, I'm just making these lengths up. But the point is that even though nearly every single type is going to take more than a single byte, about the only thing that takes a single byte is a character variable. Right, that's a single character, which is a single byte. With that being the exception, every other type, integer, float, string, I'm trying to think of other types that we've used, those are the 3 basic ones, are all going to take up more than 1 byte, but we don't have to worry about whether it takes up 1 byte, 2 bytes, 3 bytes, 4 bytes, because it will, under the hood, basically multiply this by the size of a float or the size of an integer, or in our case, the size of a string, right? Whoops, the size of a string. So with that in mind, I'm safe doing this to get at the first, the second, the third, and so on strings. So that will take that weird number we saw and add the right amount to it. The next thing is, it's still that weird number. So what I have to do is I have to do a little command here, which is an asterisk. It's not multiplication, it's an asterisk, which means give me the contents at that location in memory. Now this seems very alien, and I will make it a lot easier very, very quickly. So that would get at the first string, the second string, the third string. And presumably, they don't have anything in them. Yes?
How do you do that when you added n lines to all 3 of them, like almost simultaneously?
So what I did is I did, let me get my command here, my line of code. Okay, it's something like this. So I was probably here, and I went $sign to get to the end of the line. A for appended, space, and then I type that in, and I hit semicolon, and then I hit escape. And then here's the key thing, is to repeat the last command that I did, which in that case was to append that information, is a period. Period repeats the last command I did, so I did period, K to go up, period to repeat.
So you just press a K period?
Yeah, K period, K period. So period, repeat, last edit. Yeah, definitely. I mean, that's what you all should do. For those of you who are using Vim, you need to stop me whenever you see something that that I'm doing that you want to be able to do. All right. Now, so what I can do is I can use this weird convention, and I'll get away from it in a moment. So if this is the first string, I want to set that to Larry. So I'm going to do YY, paste, paste. I'm going to move forward onto the 0, replace with the 1, replace with the 2, curly, Mo, and then I should be able to print them out. And I'll leave that. Let me leave this down here. This is that first one where if I just specify the name of it, it's just going to give me that address where they all begin. Okay. So let me run it. Let me start at the top of the screen here. So here's that weird address. When I add 0 to that address, and then I use that asterisk, which means the contents of it, and I assign Larry to the contents of the first one and Curly to the second, Mo to the third, and then I say print out the first, second, third. It works. So again, listing the name of this array by itself gives me that weird address. I can add a number to that, and then if I take that sum and I use this asterisk, which incidentally means dereference, that's how I pull that off. Now this is a very, what do I want to say, it's visually unappealing. So there's an alternative, and in fact a more common way for me to access specific elements. So if I want to change the first item in list of names, what I can use is I can just use the square braces like this. And then what I'll do is lines 19 through 21, I will yank them, and then I'll paste them here. So I'm using the old-fashioned way here, but I'll change that in a moment. Let's see that that's working. Compile it, run it, and there's Ben and Jerry and the ice cream mascot. And so what I would probably want to do is make this match like that, and that should work just fine, and in fact it does work just fine. Okay, so this is how it really works. I can tell you I'm not going to ask you on the exam to do this kind of expression. May ask a question on arrays, but I would be assuming that you'd use this much more pleasing to the eye format for this. But I just want to make it clear what actually is happening under the hood and what this is actually doing. So when I say list of names sub-0, I'm just adding 0 to the number and then getting the contents there to either set it or to retrieve it for the cout statement. Okay? Yes?
So the Larry, Curly, Mo, and the Ben, Jerry, ice cream mascot would both work independently of each other?
I'm sorry, I didn't catch the end of it.
The two name sets would work independently of each other. Would Ben and Jerry would work without Larry, Curly, and Mo?
Yeah, there's no, all I'm doing is I'm reusing. I'm just reusing the same variables. It's like if I say int x equals 43, and then later on down here I say x equals 99, right? I'm just reusing the variable. I don't have to. I actually did create, how many of them did I create? 132 of them. I can make this 99, 100, and 101, and then I can print those out. 99, 100, 101. That works just as well. So I've got quite a few of these, and I can use them how I want. Yeah?
Do they have to be in a row? Yeah, like
99, 199, 46. Yeah, 199, darn it. All right, I got it. I was just getting a little excited there, sorry. There you go. So they can be anywhere, right? You've got 100. The point is you have 132 of them. You can do whatever you want. It's just like if you create an integer x, what can you do with x? I don't care. Do whatever you want with x. You've created it. It's yours, right? If you've created 132 strings, do whatever you want with them. Why 132? Hell, I don't know. It's your program. You tell me, right? Which is what you're asking me, and it's just because I'm a little weird in the head. That's why I chose 132, but hopefully you'd have a good reason. Yes? The way I've done it here. Is there a way of doing them all at the same time? Yes. Yes. So what is typical is that you would not necessarily know these names and hard code them into your program the way I have. So what you would do is you would do something like for integer I equals 0, I is less than 132 plus plus I, and then I would do something like get line from the keyboard. I want to read it into list of names, the ith item. Now this will, in a loop, read in from the keyboard 132 of these things. Okay.
I have a question.
Yes.
Why did you put I at the end of it?
This has to be a number, right? So I'm following this formula here. And so I starts at 0. Again, so this is the next thing to note that's quirky about C and C++, is that arrays are 0-based. Because of what I showed you here and because of the way the mathematics works, what do you add to get to the first element? You add 0 to get to the first element. So arrays always start at 0, which means if I have 132 of them, what's the highest number I can put in here? 132. If it starts at 0, I don't put 132. 131 is the highest, right? 132 items would be from 0 to 131. Okay? And so that's very important to keep in mind. So what happens is people overthink these loops, and if you mentally just kind of follow this recipe, if I have 132 of them, just put less than 132. Because what is less than 132? 131 is less than 132. So you end up with your for loop working perfectly, going from 0 up through and including 131, but it will not hit 132. Yes?
What's the point of this, I guess? Like what does this do?
So how does it make you more powerful as a programmer? What do you use this tool for in the toolbox?
Like you have to label each individual list of names.
Yes, but look what I've done here. If I tell, so you've got a lab. Let's look at your lab. Labs. All right, let me jump to the second paragraph. I have to spend the last 5 minutes talking about the first paragraph. The main function should create an array of 30 floats. Use cin as part of a for loop to read in 30 floats. So the advantage it gets you is if you are calculating the average grade point, the average GPA of this class, then you are going to find it a far easier task to use something like this loop on lines 130, similar to this loop on lines 130, lines 30 through 33, rather than naming each variable individually. Likewise, I can print them out using a for loop, right? So that the key time saver is that you don't have to hard code a number inside these square braces. You can put a variable inside those square braces, and it'll go to that particular item. So arrays are very, very handy when you have a whole bunch of something. If I need to calculate the average, what do? You loop through these things and you just add them together and then divide by the number of items. So that's the advantage. Let me go back to this assignment. So you're going to write a main function that reads in an array of 30 floats, and it's tedious for you when you're writing your program. It'd be tedious for you to test it by typing in 30 numbers. So I've actually provided a text file entitled 30numbers.txt, which coincidentally has 30 numbers in it. I know, I spent all night making it. When you run your program, you compile your program. When you run it, be sure to use this less than sign and then the name of the file. That will fool your program into thinking it's getting things from the keyboard, meaning your program uses cin, but in fact all the input will be coming from this file. So it'll just suck those 30 numbers out of the file rather than you typing them in. Okay, so that's how I recommend you test it. Or if you want to test it by hand, that's fine. Why don't you choose 3 numbers as a test? Yes?
Could we use fstream to get input from the file? Or?
You could use fstream, however, since this is submitted to turn-in, and turn-in is expecting that you have cin there rather than using files. But yes, as a general principle, as a programmer, you could absolutely use fstream, open up this file, and read in the 30 numbers. Okay. So let me spend the last 5 minutes talking about the function. So you read in the 30 numbers. After you read in the 30 numbers, then you need to calculate the average. And what I'm asking you to do is to write a function that calculates the average. So what this function takes, and what I want to focus on, let me copy this into the terminal for those staring at their computers with the terminal. I'll call this lab notes. What's really confusing about this function signature is this little bit right here. Okay? And the way you would read that as a programmer and say it out loud is you would call this a float pointer. Now, you don't have to get too hung up on it except to say that this means that this variable right here, let me take this away, that variable is a floating point number like 3.14. Yes? Beat it into the ground. That's a number like 32. Got it? This is expecting an address, which is the beginning, and now looking at my screen up here, is the beginning of a whole bunch, in my case, of floating point numbers. So a float with a star means that this variable is the address that is the beginning of a whole bunch of things in an array. So what you'll do in your assignment is you'll create your 30 floats. Call it whatever you want. What do I type to get the address that is the beginning of these 30 floats? Let me direct your attention back to here. What was my expression that what it spit out to the screen was that funky address? It's line 18. It's just the name of the variable without anything else, yes? So when I call this function average, the first argument is just simply the name of your variable without anything else. That's it. That will give you the address, the very beginning of this whole sequence of floating point numbers. And then the second one, well, the second argument will be the number 30, right? Since you have 30 elements. So when you calculate the average in this function, how do you calculate the average? You add them together and you divide by the number of elements, yes? So how do you add them together? You create a variable to hold the total, float total. Don't forget to initialize it to 0. And then you need to loop through these. What's a good convenient loop to do this? For loop, right? For loop, you're going to go, say I, it's going to go from 0 to, where does it stop? to less than. Okay, but we're inside the function. The function doesn't know how many items. So did we provide the number of items? Yes? Now inside here, you can say total is equal to total plus what? What's the name of the variable that came into the function?
Average.
Now that's the name of the function. The first argument, I called it array. You don't have to call it array, call it Bobby. So how do you say Bobby? If you want the ith element of Bobby, what do you type? After you're done with the loop, what do you do with total? Divide it by num elements.
So 30.
Yeah, but don't hard code the 30. You need to be putting in num elements. And then return that number. When you return that number, right, you'll have some variable here to grab that number and then print it out. Give me some questions. Let's see if no one's done anything.
So what does the I represent?
I is just a counter. You can call that right. Doesn't matter. It's just my for loop. So for yeah, I'm trying not to write the entire lab for you. That's what I'm trying to do. So I'm making you type main. The main function starts here. I put a comment there to indicate that's the main function down here. This is the average. This is the average function. This is the main function. Yeah. Yes.
Would you actually do non-elements, or is it actually you input the number 30? I'm trying to figure out.
You down here, you mean? Yeah, so down in main, you know how many floats you have, so you hard code that to 30 and you pass the 30 in. This function is supposed to be generic that could be used in any circumstance, regardless of the number of elements, so that's why you're providing the 30, and then you just use number of elements in here. That way, if you call the function again with 50 floats, the function doesn't have to change and it works perfectly. Okay? All right, so with that, have a go at the lab.
Okay, so just these Untitled Chapter,